In this video, we are going to discuss simple example under derivative of inverse hyperbolic function. Okay, example 1. Given y equals to inverse sinh for x. Differentiate with respect to x. Okay, from y equals to inverse sinh for x, when we differentiate y, the symbol should be dy over dx. Okay, and then we have composite function here. Okay, means that for x inside inverse sinh function. So we can draw two circles here. Okay, and then we can attach to another two circles. And in between must multiplication operation. Okay. For the first circle, we can refer from formula derivative of inverse sinh single x, which is equals to 1 over square root of 1 plus x squared. Okay. Now, our x is 4x. Okay. And then, for the second circle, we can refer from formula derivative of 4x, which is equals to 4. Okay. When we differentiate inverse sinh for x, we assume our x equals to 4x. Okay. From this formula, we replace x by 4x here. Okay. So we have 1 over square root of 1 plus 4x bracket squared. Okay. And then when we differentiate 4x, it becomes 4. Okay, from here. Okay. And after that, we need to simplify. So we have 4 as numerator and over square root of 1 plus, we expand 4x squared. So we have 16x squared. Okay. This is the final answer. Okay. Got it? Okay, we continue with example 2. Given y equals to inverse cos x over 2, differentiate with respect to x. Okay. Okay, from the given question, we have y equals to inverse cos x over 2. To differentiate inverse cos x over 2, we need to identify the mathematical operation. Okay. The relationship between inverse cos and x over 2 is composite function. Means that x over 2 is inside inverse cos function. Okay. Okay, when we differentiate y, the symbol is dy over dx. And then to differentiate composite function, we can draw a big circle and inside has small circle. Okay, because we have two composite function. Okay, so we draw two circles. And after that, for the outside circle, okay, outer circle, we can attach to this circle. Yeah. And then, from inner circle, we can attach to the other circle. Okay. And in between must multiplication operation. Okay. And then, to differentiate inverse cos, we can refer formula derivative of inverse cos x. Okay, the simplest formula for inverse cos. Okay, which is equals to 1 over square root of x squared minus 1. Okay. And then, for inner circle, we can refer formula derivative of x squared. Okay, first step, we can rewrite x squared to half x. Then we can differentiate. Okay. Now, what is the correct function inside the first circle? Okay, in second row here. Okay. Okay, we can refer from derivative of inverse cos single x, which is equals to 1 over square root of x squared minus 1. Okay, we just replace x by x over 2 here. Means that we have 1 over square root of, we replace x by x squared, brackets, we replace x by x over 2, and then bracket squared, and then minus 1. Okay? And when we differentiate x over 2, we rewrite x over 2 equals to 1 over 2x. And when we differentiate 1 over 2x, we have 1 over 2. And then we can put here. Okay? And after that, we need to simplify. Okay? When we simplify x over 2 squared, we have x squared over 4. And then we can simplify or standardize this denominator. So we have x squared minus, this is 4 over 4, so minus 4 and then over 4. Okay, we still have half here. Okay, and then square root of 4 we can simplify. We have 2 here, no more square root. Okay, and 1 over any fraction, okay, we can exchange numerator and denominator here. So we have 2 over square root of x squared minus 4 times half. And after that, we can simplify half here. So the final answer is 1 over square root of x squared minus 4. Okay, this is the final answer. Okay. Or we can use the alternative method. Okay, from appendix, formula number 18, we have integration of 1 over x squared minus a squared square root, okay, which is equals to inverse cos x over a. Okay, when we move integration sign to right hand side, so we have derivative here. So we have 1 over square root of x squared minus a squared equals to derivative of inverse cos x over a. Okay, or we can exchange left hand side and right hand side. Okay, so we have derivative of inverse cos x over a equals to 1 over square root of x squared minus a squared. So we refer from this formula. Okay, now our a is 2. Okay, and the formula is here. Okay, means that when we differentiate inverse cos x over 2, okay, we replace a by 2, the answer should be 1 over square root of x squared minus 2 squared. And then we simplify, so we have 1 over square root of x squared minus 4. Okay, this is the alternative method when we have fraction inside inverse cos here. Okay, got it? Look at example 3. Given y equals to inverse tan e the power of x squared, differentiate with respect to x. Okay, from the given question, y equals to inverse tan e the power of x squared. Okay, we differentiate y, so we have dy over dx. Okay, and then the mathematical operation for inverse tan exponential function e the power of x squared is composite function. Okay, so we can draw a circle. Okay, we have big circle here, outer circle, and then the second circle, and then the other circle. Okay, so we have 3 circles here. Okay, so after that, we can attach with another 3 circles. Okay, the outer circle we attach with the first circle in the second row. Okay, and then the second circle we attach to the second circle in second row, and the inner circle we attach with the third circle in second row. And in between, mass multiplication operation. Okay. And then for the first circle, for the outer circle, we can refer formula derivative of inverse tan x because we have inverse tan here. Okay, we refer for single x only. So derivative of inverse tan x equals to 1 over 1 minus x squared. Okay. And then to differentiate e the power of x squared, we can refer from basic formula for exponential function. So we have derivative of ex. Okay, the answer is ex. Okay. And then we differentiate the inner circle. Okay. We differentiate x squared. Okay. The answer is 2x. Okay, after that, we put the correct function inside these three circles. Okay. For the first circle, we have derivative of inverse tan. Okay, we refer from derivative of inverse tan single x. So we just replace x by e the power of x squared. Okay, so from formula, we have 1 over 1 minus, and then we replace x by e the power of x squared, and then bracket squared. Okay, and after that, the second circle, we can refer from derivative of ex, which is equals to ex back. Means that if we differentiate e the power of x squared, we have e the power of x squared also. Okay, and then we differentiate x squared, the answer is 2x. Okay, now we done differentiate. Okay, but after this, we need to simplify. Okay. Okay, when we simplify, the numerator should be 2x e the power of x squared. And the denominator is 1 minus. Okay, we need to simplify e the power of x squared bracket squared. So we have e the power of 2x squared here. How we get this? Okay, from the properties of indices. From properties of indices, we have a the power of m and then the power of n. Okay, the answer is a m n, means that we multiply the power. Okay, so if we have e the power of x squared and then squared, means that we need to multiply x squared and 2. So when we multiply x squared and 2, so we have 2x squared. So means that when we simplify e the power of x squared bracket squared, the answer is e the power of 2x squared here. Okay, got it? Okay, now let me show you how to find the derivative using symbol lab. Okay, we use the previous example, example 3. Given y equals to inverse tan e the power of x squared, differentiate with respect to x. And then we get the final answer here. Okay, from the previous slide. Okay. Okay. To solve using symbol lab, first step, we need from Google search, we need to type symbol lab. Okay. And then we have this. Okay, www.symbollab.com. Okay. And then we click this. Okay, and then we have this. Okay. From enter a problem, we choose d over dx. Okay. And then we type inverse tan e the power of x squared. Okay, from the given question. Okay, it looks like the power of -1, but it means inverse hyperbolic here. Okay, and after that, we press enter. And then we have this. Okay, the final answer is 2x here. Okay, 2x e the power of x squared here over 1 minus e the power of 2x squared here. And arch tan means inverse tan. Arch means inverse. Okay. This question, so this answer. Okay, you got it? Coming up next, derivative of inverse hyperbolic function from previous semester papers. Okay? Thank you for watching. Stay tuned. Bye. Assalamualaikum.